Hi everyone, and welcome to our last video in the ratios portion of this series. Now today we're going to look at one final application of ratios, and this is the idea of scale drawings. Now, these scale drawings, as you can see, I've got a map down here. This is the map of Australia, where I'm from. Now, an important thing to note about any scale drawing, now this can be a map. I know some of you may not be used to seeing maps, especially in this kind of new digital age. But back when I was younger, we had street directories and maps. And what these told us was it gave us an idea of how big something was. Now, obviously, Australia is a very large place. We can't put the entirety of Australia on a map. So we need to use what's called a scale factor a scale drawing. And you can see here, we have mention of a particular scale of this map. Now, this doesn't just have to apply to maps. This can apply to models. So if you work in architecture, for example, the model you make has a particular scale, something that tells us, well, how big would this be in real life? So any scale drawings So a scale drawing, what's important to note about these is that it has the exact same shape as an original object. So exact shape as an original object. But it has a different size. So we're right, but different size. That is what we mean by a scale drawing. And a scale ratio, so you can see in this map, we have actually a ratio here. That basically tells us about the size of the actual thing. So if I had, for example, we'll look at this scale ratio. So I'm going to rewrite it down here. So if I have a scale ratio of 1 to, that's 40 million. All right, this is a really big number. This means that the actual length, the real length of the thing I'm measuring, so for example, some part of Australia on this map, the real length is 40 million times more than the length measured on the diagram. So this particular thing is and all of our scale drawings and scale ratios are shown in this form. So this is the drawing length, and that is expressed as a ratio with the actual length. So that means that in this case, my actual length is 40 million times the length of my length on the map. So our scale tells us that, well, if I were to measure a distance on this map in Australia, whatever I measure it on this page, the actual length in Australia is going to be 40 million times that unit. Now, let's look at this in the actual context of a question. The main idea I want to get here is that these scale ratios and these scale drawings, we're trying to show something a lot bigger on a sheet of paper. Or if you look at models, if you're a city planner or an architect, our models of an entire city, we're obviously not going to be able to show that in a demonstration. So we want to include a type of scale factor to tell us how big this would really look like out in the world. So yeah, if you have your little building that you've designed, if you're an architect, that has some type of scale factor or a scale ratio, I should say, to the actual building when you make it in real life. And our scale ratio tells us how big this actually is. So let's look at an example. Now, a map, for example, map has the scale of, let's say, 1 to 20,000. And what we want to do is find the actual distance of each given scale distance. So I'm given the first one being 2 centimeters. So it's important here to note that this particular thing here is the actual distance. I'm going to write that as AD. And this one here is the scale difference or the drawing difference. So we'll call that scale distance. Now, this tells us that what my scale tells us is that the actual distance, when my scale distance is 2 centimeters, will be 20,000 times more than that because there's a ratio of 1 to 20,000. Now we remember ratios compare numbers. So we're saying that for each 1 centimeter in my scale distance, my actual distance is going to be 20,000 times more than that. We're just applying what we've learned from ratios. So to get from my scale distance to my actual distance, we are going to multiply by 20,000 to get, well, what would this distance actually be in the real world compared to the map? And now when we do that, multiplying 2 centimeters by 20,000 gives me 40,000 centimeters, which this is a pretty big this is a big number for the unit of centimeters, so I can convert it to meters or kilometers, which we've done numerous times in the measurement courses on this channel. So that I can write as 400 meters or 0.4 kilometers. Now, this is a much easier way to write this. So what we've actually done in this question is we've measured on our map what 2 centimeters is. So say I'm measuring the distance from one place to another on the map, and I've measured it as 2 centimeters. That means if I were to go to that exact place and walk from one part of it to another, as it's shown on the map, I'm going to be walking 400 meters. That's going to be the actual distance of this place that's shown on the map. So question B, I want to find the actual distance from the scaled distance of 5 millimeters. And what's important to note is that no matter what my units are here, my scale factor is always, my scale ratio is always 1 to 20,000. So whatever that unit is, whatever the measurement is, the actual distance is always going to be 20,000 times more than that. So I'm going to do these questions in the exact same way. I'm going to go from, 5 millimeters, and I'm going to multiply this by 20,000. And what I get for my actual distance is just going to be 5 lots of 20,000, which is 100,000 millimeters. And I can also write this as 100 meters here. So this is how we can go about using scale factors. And this can be for either for models, for maps. We use these types of ratios in a variety of different ways. Now, we've gone one way here. Let's start looking the other way. So let's look at converting the actual distance to a scaled distance. So we've gone one way, we're looking at the other way now. So I have a model boat. So a model boat, and it has a scale of 1 to 500. 1 to 500. Now, what does this mean? Well, our scale ratios, we remember, always had the scale distance and the actual distance. So in other words, this means that if I measure something on my model, my actual thing is going to be 500 times more than that. But here we're going to go the other way. So we want to find the scaled length for each actual length. Each actual length. That's what I'm looking for here. And I have part A, and it's going to be another 2-part question. So I'm going to say, find the scaled length for the actual length of 50 meters. Oops. So what's different about this question is that now I'm told that on my actual boat, I've measured a length of 50 meters. And the actual distance, the actual length, is 500 times more than the scale distance. So to get from the actual distance to the scale distance, if it's 500 times more, I can find the scale difference by dividing by 500. I'm going the other way now. So instead of multiplying by 500, I'm going to be dividing by 500, which hopefully should make sense because the actual distance is always going to be something larger than the scale distance. That's what the ratio tells us. So we would expect for the scale distance to find something smaller than 50 meters. And we always get a smaller number. Well, a lot of the time we get a smaller number when we divide by a whole number. So we're dividing by 500 here. So my scale distance is going to be, well, I'm going to divide 50 meters by 500. Divided by 500. And this is going to give me something really small. So let me convert first the 50 meters into centimeters. So 50 meters to centimeters is 5,000 centimeters divided by 500. And I get here 10 centimeters. So that means that 10 centimeters on my model of my boat is going to be 50 meters on the actual boat. So my small little boat, if I measure some length of 10 centimeters on it, when I go out and look at my massive boat, let's make this arrow smaller so I can draw a massive boat. Obviously, this isn't properly to scale. I would need much more than this portion of the page. If I were to measure my actual boat length from here to here, it would be 50 meters. And what tells us that? Well, the scale factor of 1 to 500. Now let's look at one more question. I want to find, for part B, the scaled length when the actual length is 75 centimeters. All right. Once again, to get from 75 centimeters on my actual length to my scaled length, I'm going to divide by 500. I want my scaled length to be smaller. That's why I'm dividing instead of multiplying. Now, to do this, I'm going to take 75 centimeters, divide it by 500. And once again, this is going to give me a pretty small number. So let me convert my units to 750 millimeters. And you don't have to do this unit conversion because you're going to be using calculators anyway. The question may ask you to leave your answer in meters or leave it in centimeters. But whether you write it for the sake of this video, for example, for this question in centimeters or millimeters, doesn't really matter because those measurements are telling us the exact same thing, just in a different way. So I'm dividing 750 by 500 here, and that gives me 1.5 millimeters. So to show 75 centimeters on my big boat, on my massive boat, I'm going to be looking at a very small measurement on my model. I'm only measuring 1.5 millimeters. Now, if you guys have looked at a ruler, that's a very, very small part of my scale drawing. But this is how we can interpret our scale ratios here. And we're always looking at scaling. These are always in the form of my scale distance to my actual distance. And what this tells us is that my actual distance is always a certain amount of times larger than my original. So in this case, it was, for example, 500 times larger. And in the first example, my scale of my map was 20,000 times more. In this map of Australia as well, my scale was 40 million times more. So the scale drawings, they tell us the exact shape, but a different size. And the scale ratio can give us an idea of how large this would actually be in real life. Thank you so much for watching, guys. I'll see you in the next video.